My name is Marlena Snellick with A Plus College Ready, and today we are going to look at colligative properties. So we are going to look at 4 different types of colligative properties. We're going to look at vapor pressure, boiling point, freezing point, and osmotic pressure. So let's start with vapor pressure lowering. So vapor pressure is the pressure that is created on the top of a liquid surface as molecules move from being a liquid to a gas and a gas to a liquid. And so you can't see it, but on top of every surface of a liquid there are gas molecules, and they are moving into the water to be dissolved, and they are also moving out of the water onto the surface. And so when they're happening at the same rate, we say that they are in equilibrium. What happens when we add a solute to a pure solvent is the vapor pressure lowers. So let's look at why it lowers. So if we look in the first picture, the picture of just blue, that's a pure solution, and so, or a pure solvent. So we can see the gas particles on top, the atmospheric pressure, and we can see the molecules of the solvent inside. Now, what happens when I add a solute to the solvent? Notice my vapor pressure lowers. I have a decreased number of gas molecules that are escaping from the liquid and becoming a gas on the surface. Why is this? When I add the solute interacts with the solvent molecules. So the solvent molecules try to form some type of solvent shell around the solvent molecules. Well, because so many of them are interacting with the solute and trying to dissolve them, it leaves less free solvent molecules that can evaporate away to change from a liquid to a gas. So therefore, the vapor pressure lowers. When vapor pressure lowers, it also affects 2 other colligative properties, our boiling point and our freezing point. So let's look at boiling point first. So when we decrease the vapor pressure, it causes the boiling point to elevate or to raise. This is because, like we said before, the solvent molecules are now engaged with the solute molecules. So they can't escape the liquid as a gas. Well, what is boiling? Boiling is when we get something to a high enough temperature that it causes it to change from a liquid to a gas. So because those solvent molecules are busy, it requires more energy to get the solvent to boil. So it requires more heat energy, so therefore the boiling point is raised. While it causes the boiling point to elevate, it causes the freezing point to depress or decrease. So we need more energy to get the boiling point, but it causes the freezing point to do the opposite. It decreases. Again, same reasoning. The solvent has become more attracted to the solute than other solvent molecules. So in order to get them to freeze and get into a fixed solid, it's going to take a lower temperature than it did before. So the freezing point lowers while the boiling point raises. The last colligative property that we will look at is osmotic pressure. So osmosis is the movement of water through a semi-permeable membrane. So permeable just means things are able to move through. So semi-permeable just means some things can move, some things can't. So in this case, water is going to be moving through the semi-permeable membrane. And water is going to move from an area of low concentration of solute to an area of high concentration of solute. And I always think of it as water likes to dissolve things. So it's going to go to the area where there's the most solute to be dissolved. So we have different terms for different concentrations here. So hypertonic means that we have a lot of dissolved solute. Hypotonic means we have a little dissolved solute, and we always use these terms in respect to another. So if we look at the picture, the hypotonic solution has less solute than the hypertonic solution. And water is always going to move from hypo to hyper. It's going to move from where there's a little to where there is a lot, and it is going to keep moving until we establish equilibrium. So this is just where both sides of the membrane are going to have an equal concentration, and so they keep moving back and forth, back and forth, back and forth, and it's constantly moving to maintain that equilibrium. And this sums up our lesson on colligative properties, and I will see you for the last lesson on solutions soon.